In this project, we are asked to design a non-inverting amplifier to amplify an input signal by 10 times. The input signal is simulated by a sine wave with peak-to-peak value of 230 millivolts. The first step of subsystem design is to translate the problem statement to design specifications. In this case, the requirements are: a non-inverting amplifier configuration is desired to be used. The input signal is known, and the desired circuit gain is 10. It's obvious the prototype circuit for the non-inverting amplifier configuration should look something like this. At the negative input terminal, node A, the voltage level should be the same as the positive input terminal. That is to say, the voltage level at node A is Vin. If we assume the current across Ri and Rf are I1 and I2 with the orientation as shown, we could write out two equations for I1 and I2 respectively, based on Ohm's law. Since the current into the negative input terminal IB is equal to 0, at node A, we have the KCL equation I1 is equal to I2. Substitute I1 and I2, we'll have Vin over Ri is equal to Vout minus Vin over Rf. From this, we could derive the circuit gain, which is defined as the output over input, is equal to Ri plus Rf over Ri. As for the circuit design, we could use a 10K for the input resistance and 100K for the feedback resistance. This should give us a theoretical circuit gain of 11. Let's see how it works. So the gain is defined as Vout over Vin, which is equivalent to Ri plus Rf over Ri for non-inverting configuration. This is equal to 10K plus 100K over 10K, which is 11. This is greater than the desired circuit gain, 10. So when we have a sine wave with amplitude of 230 millivolts for the input signal, theoretically, we're going to have the output signal with the amplitude about 2.5 volt. Let's build the real circuit. The positive power is red and negative power is dark. Both of the green wires are ground. This is the input resistor and feedback resistor. The input signal from the function generator and output signal to the scope. Now connect all cables for the power supply, function generator, and oscilloscope. We show both the input and output signals simultaneously on the scope. Channel 1 is the input and channel 2 is the output. It's obvious that those two signals are in phase. This makes sense because the circuit gain has a positive magnitude. And this is also one of the reasons for the name of the non-inverting amplifier. As for the amplitude of the signal, the output is a little bit lower than expected. Go back to the design specifications. We use a non-inverting amplifier to amplify an input signal, and the experimental gain is around 9.7. The experimental error is about 11%. This error might come from the tolerance of the resistors. Even though the experimental gain is very close to the desired value, if we want to use this circuit in real application, we might want to go back to the original circuit design. For example, we could increase the feedback resistance and retest the circuit to make sure it's above the desired value. Both the inverting and non-inverting amplifiers are very useful in biomedical field. A lot of biological signals, the original sensor signals, are very weak. For example, the ECG signal is up to a few millivolts. And generally, we need those amplifiers to amplify those signals for us.